Hey girls, this is Blaufuss. This is about lesson 3.5, constructing parallel lines. So already we've constructed line segments and we've constructed congruent angles. And so we're going to use both of those to construct parallel lines and then polygons that relate to parallel lines, like a rhombus or a parallelogram or a trapezoid. So in this lesson, we're going to go over a couple methods of constructing parallel lines, but we're going to start with defining parallel lines. So we've defined this before in chapter 1, but parallel lines are lines in the same plane. They have to be in the same plane that do not intersect, or will never intersect. So the first group, not parallel, you can see clearly that they intersect. The second one, even though they don't intersect in the diagram, it doesn't mean that they won't ever intersect. So eventually they're going to intersect. You can tell eventually they're going to intersect. And then thirdly, they're parallel, they are never going to intersect. The distance between this point here and this point is the same as the distance between these 2 points. Okay, so if the distance between all of the points on the lines, both of them, are the same distance from the other lines, then they are never going to intersect, therefore they are parallel. So we had on your note sheet, from this, you can see this parallel lines conjecture. This is from lesson 2.6, and it says if two parallel lines are cut by a transversal, then corresponding angles, alternate interior angles, and alternate exterior angles are all congruent. The converse of this is also true. So if you have corresponding angles that are congruent, alternate interior angles that are congruent, and alternate exterior angles that are congruent, then you have parallel lines that are cut by a transversal. So the conjecture is true, and also the converse is true. So let's just kind of recap. What are corresponding angles? So if you look at this diagram, which is not on your note sheet, but if you look at the diagram, corresponding angles are angle A and angle E. Those two angles are corresponding. And with parallel lines, you can mark these parallel. With parallel lines, that means that they are congruent. Okay, so angle A and angle E are corresponding. Also angle B and angle F are corresponding. And angle C and angle G are corresponding. And angle D and angle H are corresponding. Okay, so that's one part. Corresponding angles are congruent if you have parallel lines cut by a transversal. The second, alternate interior angles. Okay, so the second part of our conjecture says alternate interior angles are congruent. So let's look at some alternate interior angles. So we're focusing on angles that are on the interior of these parallel lines. So that's C, D, E, and F. Those are our interior angles. So the alternate interior angles are interior angles that are on alternate sides of the transversal. So angle C, angle C, and angle F. Those are alternate interior angles. And angle D and angle G. And angle E, I mean. Angle D and angle E, angle C and angle F. Those are alternate interior angles. And then the last one is alternate exterior angles. Okay, so now let's look at the diagram and see if we can figure out what angles are alternate exterior angles. And again, this is from lesson 2.6, so you've already taken a test on this, but hopefully it's coming back to you pretty quickly if you forgot. So the exterior angles are A, B, G, and H, and the alternates are the ones that are on opposite sides of the transversal. So angle A and angle H are alternate exterior angles, angle G and angle B are alternate exterior angles. Okay, so now with all of this stuff, we're going to use this to construct parallel lines. So again, the conjecture is true that if you have parallel lines cut by a transversal, then corresponding angles, alternate interior angles, and alternate exterior angles are all congruent. And the converse of that, if you have corresponding angles, alternate interior angles, and alternate exterior angles that are all congruent, then you have parallel lines that are cut by a transversal. Okay, so now constructing parallel lines, we're going to use our compass and our straight edge to draw a line and a point that is not on the line. So use your straight edge, draw a line, and draw a point. You can label it if you want, you don't have to. Now we're going to construct a second line through the point that's parallel to the first line. Now, there's only ever one parallel line that goes through a specific point. So to one line, there's only one other parallel line that goes through a specific point. So this is the only parallel line. This is the only line that's going to be parallel to this line that we just drew that goes through that point. And we're going to do that by duplicating alternate interior angles. That's one method. So in order to have alternate interior angles, though, we need a transversal. So draw a transversal. It doesn't matter where it is, except that it has to go through that point. Okay, so here's my transversal. Just so that you can tell it's a transversal, I'm going to make it thinner. Okay, so here's my line. Here's my transversal. Here's my point. Now I need to construct a parallel line by duplicating the alternate interior angle. So here's one angle. And I have to duplicate this angle, and I have to duplicate it so that it's an alternate interior angle. So right now, it's on the right side of the transversal. My new angle is going to be on the left side of the transversal because that's how it becomes an alternate interior angle. It's going to be inside the two parallel lines, but on opposite sides of the transversal. Okay, so just like you duplicated the angle, start by drawing an arc. And then the second step is to measure how big that arc is. So I'm going to put my center where my arc intersects with my line. And I'm going to measure just exactly how big this arc is. Okay, so here's exactly how big that arc is. Okay, and then I'm going to take my compass and I'm going to move it up, not to the vertex, but just like we were duplicating an angle to where that original arc, or my orange arc, intersects with my transversal. Okay, now I have 2 points. 2 points form a line. So my parallel line is going to go through my original point and that new point that I just constructed. So now because you have alternate interior angles congruent here, since those two angles are congruent, you have parallel lines. That's part of the parallel lines conjecture. And actually, that's the converse of the alternate interior angles conjecture, which is also true, as we talked about in chapter 2. Okay, now I want to go through a couple practice problems. So in class, we did number 4 and number 5. So pause the video while you grab your book, and we'll look at those practice problems. Okay, now number 4 is asking, it's on page 171 to 173. It's asking to construct a parallelogram with two consecutive sides, y and z, and angle A as one of the acute angles of the parallelogram. So a parallelogram, if you remember, has two pairs of congruent parallel sides. So those two sides are parallel, and these two sides are parallel. So this is what a parallelogram looks like. Okay, parallel, parallel, and parallel, and this is parallel. Okay, also this side is congruent to this side, and this side is congruent to this side. And also opposite angles are congruent. So this angle is congruent to this angle, and this angle is congruent to this angle. Okay, so that's what a parallelogram looks like. Those are the properties of your parallelogram. Now we're going to actually make one of those. So I'm just going to move this off to the side so we can see it. Okay, now we're going to start by making our sides and our angle. So actually maybe we should start with our angle first. Now you can trace your angle if you want, or you can measure your angle. Really, we're looking for the process here, so any angle will work really, but it says to use angle A, so let's do that. Okay. So here's angle A, it's 45 degrees. And we want one of the sides to be y and one of the sides to be z. So let's start there. Let's get one side and the other side. All right, so here's how big y should be. I'm going to put y on my base. Okay, so that's how big y should be. And the z should be, we're going to measure it. You can use a ruler if you want just to get started, but it's pretty easy to duplicate these angles. I think it's maybe even a little bit easier to duplicate them using a compass than it is to use a ruler. But however you want to do it just to get started is fine, because it gives you those specific measures. Okay, so here we go. This is y, and this is z, the side length. And then that angle is A. All right, now we're going to duplicate that angle. Now we can use corresponding angles conjecture, we can use alternate interior angles conjecture, we can use alternate exterior angles conjecture. It doesn't matter which one we use. This angle, since our parallel line is going to go like somewhere over here, we can see that 45 degrees is an interior angle, so we're not going to use the alternate exterior angles conjecture because that wouldn't make sense since it's an interior angle. But we could use the corresponding angles conjecture if we wanted. And that would say that if we made this parallel line, that this angle right here would have to be 45 degrees. So let's do it that way. Since we already did one using alternate interior angles, let's try one with the corresponding angles. So this is going to be your vertex right here. Okay, and then we're going to do a corresponding angle that is congruent to this first angle. So we already have one side of our angle to start constructing our parallel line. We already have one side, but we need to duplicate this angle. So get your compass. First step in duplicating an angle is drawing an arc. So it can be any size arc, doesn't matter how big or small. All right, so start by drawing an arc here through across that angle. And then you're going to want to draw the same size arc here. And you might have to extend, like I'm clearly going to have to extend this segment a little bit. So use your straight edge. To extend your segment if you have to, so that it actually intersects with your arc. Oops. I'm going to have to make mine a little bit thinner. All right, so now I've got like my arc through my transversal. Now I need to actually figure out how big this angle is. I know it's 45 degrees, but I'm not going to use my protractor. All right. And then I'm going to do the same thing from where my arc intersects with my transversal. Okay, so now I've got 2 points for my line. I'm going to I'll make it lightish blue. Okay, so it's going to go through this point here and through that point. Okay, now I also know that it has to be the same length as y, okay, because my opposite sides for my parallelogram are going to be congruent. So I can construct another parallel line to z if I want, or I can just make sure that this is y, okay, and either step you do will give you a parallelogram. But I think it's a little bit easier to duplicate a segment than it is to duplicate an angle. So that's why I'm going to do it this way. Okay, and again, if your segment isn't long enough, you need to extend it. Okay, and then my last one is I connect my 2 endpoints. So my 2 endpoints of segment y together. And I'm going to use darker blue for that. And if I measure this, it should give me segment z. So I'm just going to measure just to be sure. Okay, mine's a little off, but there we go. Same as measure as segment C. And if I measured my angle, I would get 45 degrees here. And then these opposite angles would also be congruent. They should be 135 degrees. So just to check, just so you can see, you can get your protractor out if you want. But here we go. This one is 45 degrees. Oops, sorry. This one is 45 degrees, which is what we started with. And then if we rotate it and measure this angle, should get 45 degrees, which we do. And then if we rotate it again and measure this angle, we get 135 degrees right here. And then if we rotate it again to find the last angle down here, we get from here to here 135 degrees. So there's our parallelogram. Now the next one, number 5, is another one that we did in class. And it's the same idea. You're doing the same thing, except you're doing a rhombus. So try number 5 on your own. You need to know the properties of a rhombus. So a rhombus looks like this, and a rhombus has all 4 sides are congruent. So it's a parallelogram, but instead of having 2 pairs of congruent sides, you have all 4 sides congruent. So all 4 sides are congruent, and then it follows all the other same properties as a parallelogram, where opposite angles are congruent. Not all 4 angles, but the opposite angles are congruent. And then you have 2 sets of parallel lines. And to do this problem, you can either use alternate interior angles conjecture, so duplicating alternate interior angles to find a parallel line, or you can do corresponding angles conjecture, or you could do alternate exterior angles if you wanted. Now, if you do alternate exterior angles, you have to find the measure of this exterior angle, or you have to duplicate this exterior angle. Now you can do that and it'll work. Everything will work just fine. So either way that you want to attempt this problem, but just remember that these are the properties that you're looking for in your rhombus. So all 4 of those sides should be equal to x. So please jot down any questions you have, and then we can go through this together in class next time I see you. Thanks.